Today, we're going to talk about how to find the vertical asymptotes, the horizontal asymptote, and holes in a rational function. When you are looking for the answer for vertical or horizontal asymptotes, you're looking for an equation. And when you're looking for a hole in the graph, you're looking for a point. When we graph key features for rational functions, we're also going to eventually talk about x-intercepts, y-intercept, and domain and range. If you have no idea what rational functions look like, here are some examples of rational functions. I'm actually going to type one of these into my calculator just to see what it looks like. For 4 over x in my calculator, I can just click 4 divided by x, type that in, click enter or graph, and I will see the graph onto my calculator. We can tell that this looks way different than a parabola or a line. So if we look at this graph regraphed, I'm going to do it in slow-mo so we can watch it graph. You can see that the graph comes really close to the x-axis, and then it goes really close to the y-axis. It kind of jumps and does the same thing at the top right in the first quadrant. That's because this graph has asymptotes in there. So asymptotes are kind of like these barriers that are making our graph have this particular shape. So first we're going to talk about how to find the horizontal asymptote, that horizontal barrier that graph is coming really close to. To find your horizontal asymptote, you're going to analyze the degree of the numerator and the denominator. And you've got 3 separate options. The first option that we're going to talk about is when the degree of the numerator is smaller than, less than, the degree of the denominator. So here when we look at this example, 2x to the power of 1 is degree 1. It's a linear term. When we look at the denominator, we should notice that this is in standard form. So we're looking for the term with the biggest exponent, which is x squared. This is degree 2 because this is a quadratic trinomial. So we see that we have smaller numerator's degree over bigger denominator's degree. When this happens, when you have numerator's degree is smaller than denominator's degree, your horizontal asymptote is y equals 0. That's just the rule. It's something to memorize. It's something to learn. It's something to practice in your brain all the time. You definitely want to write the horizontal asymptote as y equals 0 because remember, we're looking at the equation of a horizontal line. So y equals 0 is actually the x-axis. Let's talk about that second option that you could have where the numerator's degree is equal to the denominator's degree. So when I look at this particular rational function, I see 2x to the first. So we're looking at the largest exponent in that binomial. And here in the denominator, we also have degree 1 because we have another linear binomial. So when the numerator's degree is equal to the denominator's degree, the horizontal asymptote is going to be, now listen carefully, the ratio of the leading coefficients in the numerator and the denominator. So what that means is that I'm going to get y equals a fraction. That fraction is going to be made up of the leading coefficient of the numerator over the leading coefficient in the denominator. So here my lead coefficient of the numerator is 2 and the leading coefficient of the denominator is 1. So my horizontal asymptote is y equals 2 over 1, which is just 2. So again, numerator's degree is equal to denominator's degree. Your horizontal asymptote is a ratio of the leading coefficients. The last option that you can have is if the numerator's degree is larger than, greater than the denominator's degree. So when we look at this example, we see that the numerator is degree 2, it's a quadratic binomial, and the denominator is degree 1 because you have a linear binomial. So when this happens, you have no horizontal asymptote. You have what's called a slant asymptote. You only talk about slant asymptotes past algebra 2. So you might talk about a slant asymptote in pre-calculus or calculus, but for now, we're just talking about when the numerator's degree is larger than the denominator's degree, there's just no horizontal asymptote. So the thing you have to memorize is that when you are trying to find the horizontal asymptote, you are analyzing the degree of the numerator and the degree of the denominator. And then you kind of have to memorize these 3 options. So in this cloud over here, you've got those 3 options: when n is less than d, when n is equal to d, or when n is greater than d. When we are looking at vertical asymptotes and holes, they go together. They both come from restrictions in our domain. The vertical asymptote is going to come from the denominator when we set the denominator equal to 0, and a hole is going to come from any factors that might cancel. Remember that this vertical asymptote is going to be a line, an invisible line, and the hole is going to be a point, an x comma y, that doesn't exist on the graph. There are a lot of options that could happen here, but the three basic ones are a vertical asymptote with no hole, a hole with no vertical asymptote, or you could have both, or you could have multiple of both, or you could have multiple vertical asymptotes, or you could have multiple holes and no vertical asymptote. So you have lots of combinations, but we're going to look at the three basic ones first. So with this first example, we're not going to find a hole because we can't factor anything here, so we can't cancel anything out. Remember that you can't cancel those x's because they're separated by plus signs. So we're just going to set the denominator equal to 0. We'll find x equals -2, and that is our vertical asymptote. You set the denominator equal to 0, and boom, you got a vertical asymptote. Those come from our domain restrictions, like we found when we were solving rational equations. The next example we're going to look at is when there is a hole but no vertical asymptote. So here we'll look at the example y equals x squared minus 9 over x plus 3. We can definitely factor this numerator into x plus 3, x minus 3. This is a difference of squares. And when we factor this, we should be able to tell that we can simplify something. We can cancel out those x plus 3's, the like quantities. When this happens, you should hear an alarm go off in your head. Woo, 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 woo. We found a hole in the graph. We found a hole in the graph. A hole in the graph comes from when something cancels out, when you have some sort of factors that cancel out. So to find that hole, you set whatever canceled out equal to 0, and we get -3 here. But remember, we're looking for a point on a graph that doesn't exist. So we're going to take whatever is left after we canceled, which here is y equals x minus 3, and we're going to substitute that x equals -3 in for x. So like input-output table from Algebra 1. When we substitute -3 in for x into whatever's left over, we get -6. So we have a hole at -3, -6. So something to memorize. The hole comes from when you cancel something out and you're looking for a point. Because there's no denominator left after we cancel, there's no vertical asymptote here. The last option that we're going to look at today is if you have both a vertical asymptote and a hole. So this equation almost looks exactly the same as number 2, but it's going to look completely different when we start doing the math. So we factor that x squared minus 9 the exact same way. It's a difference of squares, x plus 3, x minus 3. We can see that we can cancel out those x plus 3's. So there's your alarm. Wee, wee, wee. Where's a hole in the graph? There's a hole in the graph. Once you find that x value of the hole by setting whatever you canceled equal to 0, you're going to substitute that x value into whatever's left. Be careful here. What we have left right now is y equals 1 over x minus 3. That x minus 3 is not just going to magically float up to the numerator. That denominator is the Titanic. It is staying at the bottom of the ocean. Don't move it. When I substitute this -3 in for x, I get 1 over -3 minus 3, which is going to give me a different y value than the hole in number 2 gave me. This gives me a hole at x is -3 and y is -1 over 6. Don't put that negative in the denominator when you write this. We're not children. We are a little bit grown. So leave that negative off to the side or up with the numerator. Now, don't get carried away. We still have a denominator, which means we have another restriction, which means we have a vertical asymptote. Because this still has a denominator, I can still set that denominator equal to 0, and I end up with x equals +3. So in this example, I have a hole because something canceled out, and then I have a vertical asymptote because I'm left with an x in the denominator. You could have multiple vertical asymptotes. You could have multiple holes in your graph. You could have one and not the other. There are endless options here. We're going to try a few of these. Remember that to find your horizontal asymptote, you are analyzing the degree of the numerator and the degree of the denominator. For your vertical asymptote or your whole, you are looking at your denominators. You're looking to see if anything cancels. So pause the video here and come back when you're done so we can check these. All right, so we should notice that the degree of the numerator is larger than the degree of the denominator, which means we have no horizontal asymptote. We can't factor anything, so nothing cancels. So we just have a vertical asymptote at x equals 1, and there is no whole because nothing canceled. Let's look at this next one, 4 over x. This is the first one that I graphed, so we saw that it had 2 asymptotes. Let's see if we can find them both. Pause the video here, try this one, come back when you're done. So because the numerator's degree is smaller than the denominator's degree, our horizontal asymptote is y equals 0. Our vertical asymptote is x equals 0 because we just set the denominator equal to 0. And we have no whole because nothing canceled. All right, take a look at this last example. Pause the video here, try it, and come back when you're done. You better notice that you can factor the numerator and the denominator here. Both numerator and denominator are degree 2, and this is how they factor. And if you don't know how to factor, you're in the wrong place. Let's go learn how to factor first. So since the degrees of the numerator and denominator are equal, that means our horizontal asymptote is the ratio of our leading coefficients. So here we have 1 over 1 because the leading coefficients in both numerator and denominator are both 1. Because you have x minus 1 cancel out in both numerator and denominator, that tells you that you have a whole. You set that thing that canceled equal to 0. Once you find the x value of the whole, you substitute that into the equation that's left over for x to find y. So here, your whole is at positive 1, 5 over 2, or positive 1, 5 halves. Even after we cancel in this one, we still have a denominator. So if I set that denominator equal to 0, I'm going to find my vertical asymptote at x equals negative 1. We have a whole and we have a vertical asymptote. That's it for today. Keep practicing. If you can teach somebody how to find the horizontal or vertical asymptote or whole, then that's how you know it. Have a great time practicing. Bye.